Hey guys, I recently bought this amplifier just for test use, you know, when I'm building speakers or doing some sort of audio applications, audio projects, just as a little stereo amplifier to power whatever project I'm working on. So it's just a TPA3116, this little amplifier that you see on eBay, 50 watt times 2 apparently. I'm going to take that with a grain of salt. So it came the other day and I opened the packet and I was quite impressed with the quality of the casing. It's all aluminium, nice brushed and anodized or lacquered or something there. It's like nice and smooth and shiny. Toggle switch on the front, volume control, feels pretty smooth. And then on the back we got the usual RCA stereo input. We've got some banana jacks. They're kind of small ones, but they certainly work with banana plugs. And if I bring it up close, you'll see they got the usual little hole in there. You can stick your wires through or wrap them around or whatever. So it's definitely not a bad little unit from the outside. Doesn't come with a power supply though, but the listing says it works from 12 volts to 25 volts. We'll see what the caps are like inside to see what they're rated at. But I reckon a 19 volt power supply from an old laptop would work quite well with this sort of thing. So that's the outside basically. You can see on the front there, it's a Breeze Audio TPA3116 mini power amplifier. So there's a few different versions of this on eBay. You know, gold cases, rounded cases, different things, but they seem to probably use the same basic topology inside, just a different case from different manufacturers. But we'll open this up, see what's inside and see how good quality it is. Alright, getting in was pretty easy, just a few screws and Allen bolts. Allen bolts on the front to look fancy, just standard Phillips screws on the back. You can see here that it's a standard kind of extrusion case. What they do is they put a tongue and groove, one side's tongue and one side's groove on the U pieces. Then when they cut the single extrusion, you can kind of turn it over and flip it, and the tongue and groove just fit together. That way they only have to use one extrusion profile to make both sides of the case. A very common way of doing things. And then we've got the front panel there, nice thick machined aluminium, clearances for the switch and the knob, the volume knob, and our circuit board. I've just left this here on because otherwise I'm going to have to desolder stuff and I don't want to mess around with that. It's too much work. You can see we've got a heap of input capacitors here, some inductors and other film capacitors. Under this heatsink, that's where our main amplifier chip is. Volume control, I'll talk about that in a little bit because that's, it could have been done a little bit better here. Power switch and our input and output. Then on the bottom, we've got a few what look like bodge caps, but they're actually seem to be designed to be there. They just laid them flat to fit the close proximity of the case. It's got to be not too much room in there. So yeah, it looks like we can take off the heatsink for our chip. So I'll take that off and we'll have a close-up look and see what sort of stuff we've got on this circuit board. Right, so here's a close-up of the board. I've taken the heatsink off. You used to see here, and there is actually some heatsink compound. So sometimes I'll neglect to put that on, but here they have. I did notice the screws are a little bit loose. Not loose as such, but barely finger tight. So I don't want to put too much pressure and crush a chip, but I might put some spring washers on the mounting screws when I put them back in, just to give a little bit of spring pressure so as it expands and contracts with the heat, it'll have a constant downwards pressure. Kind of like the springs I have on the CPU heatsink to hold it down at a constant pressure. So it looks like we've got Sanyo caps here on the bulk noise filtering, or the input capacitors there. They will help to filter noise but also give a boost of power when you get like a bass hit. That's like a reserve of juice to give this enough power to give you a nice bass hit. So they're Sanyo, and they are a WX series, which is low ESR, low equivalent series resistance, and a high ripple current rating. Not too bad caps, and they seem to be genuine. If they're not genuine, they're very, very good copies. All the colours and the artwork on the side of them, all the writing and that seems to match up with the genuine article. So yeah, not a bad not a bad little surprise there. Often with the cheap Chinese stuff you get fakes or you get no-name brands, but these are actually a real brand. And along with the capacitors here, these are Weimer's MKP10s. They seem to be genuine as well. Weimer is a very good brand for film capacitors. So no complaints at all. I did notice that these output inductors, this is like the output filter circuitry, they're kind of flapping in the breeze a little bit, so I might put a bit of hot snot, some hot melt glue on there just to stop them from vibrating and, you know, wobbling around and potentially snapping off. Now, it looks like this will kick out 50 watts, but if you put 21 volts in, it's got a rated output of 50 watts at 10% distortion. That's a lot of distortion. That's basically not really listenable. It's going to be noisy as all hell. But if we drop that down to a 25 watt output, we drop down to a much more respectable 0.1% total harmonic distortion. So yeah, it can do 50 watts, but it's going to be pretty horrible. So yeah, like I said, you're not often going to be turning it up that loud anyway, so yeah, not too much of a problem. It's mainly just for, you know, big bass hits and that sort of thing, where you're going to be reaching that sort of power output. The chip is rated to a maximum of 30 volts, but general use for like a normal usage, you wouldn't want to go over about 26 volts. So if you have a 24 volt power supply or a 19 volt from a laptop charger, that'll work quite well. The capacitors here though are what are they? They're a 470 microfarad each, and they're 25 volts. So I wouldn't go above 24 volt. Even that might be pushing it a little bit, but if you've got a well-regulated power supply coming in, 24 volts is the maximum I'll go. Definitely not more than that, because you'll start popping these and letting the insides out like popcorn. But the rest of it seems to be pretty good. These ones are 250 volt rated, just because that's what they are with being filmed. They're often high voltage rated. These ones look like they're probably 100 volt rated, and these little ones here are 50 volts. So yeah, it's just these capacitors. So if you wanted to run it at 26 volts, which isn't really, there's no real need to, you would have to upgrade these. But yeah, 24 volts is fine. Now the thing I was mentioning about this volume knob, I mentioned that before. You can see it's got like this knurling or these slots, and then there's a slot cut clean through. This is a common way of making these pots, so that when you get a knob, it just kind of interference fits, slides on under the spring pressure of these resulting two tabs from that slot. So it's a little bit springy, and when you push the knob on, it kind of just slides on. That's what that's designed for. But the knob that they've used, there's no knurling on the inside of there, and it uses a grub screw there. What can happen is, if that grub screw is lined up on the flat side here, when you tighten that up, it compresses this and it can snap one of these off. When you use one of these sort of knobs with the grub screw, you really need a D-shaped shaft where it's a solid shaft with a flat on one side. And that flat is where the grub screw goes. So it would have been nice to see that on here. These were probably a little bit cheaper. You just got to make sure that if you take this knob off and you put it back on, you want that grub screw to line up so it's pushing into the groove. That way it's going to try and separate those and push them into the inside of the hole and make them nice and firm without actually breaking them off. Like I said, if it pushes on the side, it's going to bend it in, and that one that's pushing on will just snap off. Trust me, I found it out myself, first-hand experience. If you're really worried about it, or if you're stuck with this sort of pot and this sort of knob in one of your own projects, what you can do, and I've done this before, is get a little bit of maybe, what's that, 1 or 2 millimeter thick aluminium, cut a little piece off and slide it in, and that will hold in there, and then that will stop that from compressing, and you can get it nice and tight. Works quite well if you're stuck. But the ideal solution would be to have a D-shaft style there. But apart from that, it's not a bad looking piece of equipment on the inside. It's yeah, for the price I paid for it, about 2,700 yen, about $30. I'm quite impressed with that quality for that price. So what I'll do now is I'll replace this heatsink compound, screw that back down there. I'll put the the hot glue on here just to stop those from flapping around in the breeze. We'll put it together and we'll give it a quick test. So I've put the heatsink back on. I thought I'd make a quick note about this. It's about the right size for the reference design according to the datasheet. A little bit shorter, but a little bit wider. Always bigger is better, but this is about the minimum size according to the datasheet. The correct size for the 50 watt output anyway, at 10% harmonic distortion. But one thing I noticed was that in the datasheet there was actually two little feet where the screws come through, so when you tighten it up it doesn't bend the PCB. See, this heatsink is completely flat on the bottom, so if you've got the heatsink, which won't bend, and you tighten the PCB up, it's going to go like this and bend the PCB around the chip, and that's going to put stress on the chip and eventually break it. The reference design has feet to stop that from happening, so it doesn't matter how tight you do the screws, it's got a minimum spacing that will prevent the chip from being crushed. Now, turns out that spacing is 1mm. I found that M3, these are M3 screws, M3 washers are 0.5mm, so you might be able to see in there if I hold it up. If that's going to focus. You can see there's some washers in there. I put two 0.5mm washers in there, and now when I tighten up these screws I can tighten them up as much as I want, and it's not going to crush that chip, and it's going to be perfectly spaced. That way the PCB stays nice and flat. It's not going to be a problem at all. So I've put some spring washers underneath here, and that's going to prevent those from coming loose with the expansion and contraction of the heat. And yeah, it's nice and secure, not going to crush a chip at all, and we're all good. So I'll go ahead and put the case back together and we'll give it a test. Alright, so how does it sound? Well, I've got my speaker here, Onkyo speaker. This is just from my computer speakers. I'm only using one at the moment because the other speaker is powered and it has an inbuilt amplifier which then powers this one. So this is an unpowered speaker, so I can hook it up directly. The other one, I can't hook it up directly at all. So we're just going to run it mono, which is no big deal. I'm just using half the amplifier. It's still going to sound the same. I've got the input here coming from my power supply, which is a 24 volt 2.7 amp, and got the phone plugged in here through just on the one side that the speaker is on, just a mono plug here. So obviously the YouTube isn't going to let you hear what it actually sounds like, but it sounds rather anemic. I'll turn that horrible dubstep off. I'm not sure exactly if it's the speaker. Maybe the amplifier for the speaker that's in the other speaker has an EQ curve on it, but I doubt it. It may be a function of the output capacitors. It doesn't have an... Oh, shit. Ah, we popped it. Look at this. Blew the cap right off the top. There it is there. It's hit the inside of the lid and kind of flattened it. It went off with a little bit of a bang. But yeah, this one here is starting to bulge too. That one was about to pop. Jeez. The thing is, the listing says this is good for 12 to 25 volts. And I'm using a 24 volt power supply. Center positive, and this is a center positive, so everything matches up. 1 volt under what the rated specs say, and still went pop. So don't know what's going on there. One of two reasons. It's going to be one of two reasons. One is they're running on the ragged edge, 24 volts through a 25 volt rated cap. It shouldn't pop, but if we got a cap that's a little bit maybe just let go. But I would expect to be able to at least go a little bit over the rated voltage. You know, 25 volt. You want to go at least to about 27 before it starts having problems. You would expect a little bit of leeway here and there, but no, I wasn't over 25 volts. The other option, or the other thing it could be, is maybe these aren't actually Sanyo caps. I'm not going to say definitely that they're fakes, but I'm also not going to say that they're definitely genuine. You know what I'm saying? So I'm going to have to go and send some emails, see what the seller's going to say about this. So I'll see what happens, and if they let me keep it, I'll go down to Akihabara and get some new caps, and see how it works when we get it fixed. So I sent an email to my friendly neighbourhood eBay seller and they've given me some good news. They're going to send me another one of these free of charge and I get to keep the old one. So I'm going to have 2 lumps of shit sitting on my desk. Fantastic. But I also went down to the rolling fields of Akihabara and under the shade of a maid cafe, I picked some farm fresh Rubicon capacitors. These ones are 35 volt rated, 470 microfarad, so the capacitance is the same as these, just they're a higher voltage. So we got 10 or 11 volts overhead rather than just the 1 volt of these ones if we're running this off 24 volts. These will do anyway. They're a Rubicon ZLH. So they're in the ZL series, which is a very good series of Rubicon capacitor. They're a low ESR, and I believe the ZLH is also low inductance. But they are very good, 105 degree rated, good brand, shouldn't be a problem whatsoever. So I will go ahead and replace these capacitors, these input filter capacitors, and then let's fire it up and see what it does a second time. There they are, new ones installed. Perfect. Fit there just nicely. So I'll put the case on, we'll get some speakers and we'll hook it up and see what happens this time. We're all connected up. We got audio coming out the back to these 2 speakers. I dug these out of the home theatre. They're just Pioneer bookshelf speakers for the surround sound, so they should sound a lot better. The Onkyo, I think, had some EQ curve that this couldn't supply. Couldn't do the EQ curve, so it sounded a bit anemic. Either that or it was when the capacitor was dying, they're doing something funky and killing the bass. I'm not sure, but we'll see how it sounds with the Pioneers. We've got a stereo coming in from the phone, and we've got the power supply ready to plug in here. But first, before we plug that in, I'm just going to double check the voltage, just to see if it is 24 volts as the power supply states. And we're 24 volts right on the knocker. Perfect. No worries. So it wasn't an over voltage condition from our power supply, it was just rubbish capacitors. So let's plug this one in, turn it on, and we'll see how it sounds. We'll turn that down now. Sounds good, actually. Sounds a lot better than before on that Onkyo. So I fixed it. It works. It sounds good. It does what it displays on the box, and there's no problems there now. But can't recommend it at a 24 volt power supply because of those capacitors blowing up. Unless you're willing to get in there and pull those old caps out and put better ones in, yeah, it's going to cause you grief. But they are sending me another one, so what I'll do when that one turns up, YouTube time, we'll fast forward, and I'll see you just in a sec. So the eBay seller came through, got my replacement for the one that burst, and we put these new caps in. Put that one aside. So this is the, it looks exactly the same, this is a new one. We'll open it up and just have a quick look inside. I'm expecting it to be exactly the same. Ta-da! Exactly the same. Just as I thought. So we've got the same capacitors, which apparently are Sanyos. They are 470 microfarad at, can I see it? 35 volts. Oh, they're at 35 volts. I'm pretty sure the last ones were 25 volt. Yeah, these ones are definitely 35 volt, whereas the old one had 25 volt rated caps. So they must have had a design revision. Maybe I just got luck of the draw and got the old revision, blew the cap, so they sent me a new one which happens to have the 35 volt rated cap. So it looks like they probably won't go pop, which is a little bit disappointing because I've got the new caps ready to go in. Well, that was a little bit anticlimactic. Couldn't pop the caps, and if I up the voltage enough to actually get them to pop, go to 35 or more volts, I'm going to blow that chip. The absolute maximum rating on that is 30 volts, so as soon as I hit that, that chip's going to fry. The nominal working voltage is about 26 volts, so normal operation you don't want to go over that. But hit 30 volts, that's going to go pop, and the caps aren't even going to blink because they're rated to 35 volts. So I don't want to do that because I would like to use this, and I don't want to pop that and make it completely useless. It's a surface mount chip and it's not even worth repairing it if you blow that. So yeah, if you decide to buy one of these, I would recommend you check what caps you get. This one had the 25 volt, this one had the 35 volt, so just open it up, have a look. If you get the 25 volt caps, either upgrade them or just run on 19 volts, like a laptop's power supply. If you get the 35 volt rated caps, you go to the full 24 volt power supply, no problems whatsoever. So I'll give this a tentative sideways thumb, edging towards a slight thumbs up, because it does sound good when it works. Good bass. It feels like a nice pot there for the volume control. The case is definitely a nice quality to it, but the caps, and the average user isn't going to want to open this thing up and start soldering, you know, capacitors and upgrading things when they just want to buy it and use it. So yeah, apart from that little buyer beware, it's not a bad quality product, as long as you get the 35 volt rated caps, of course. So I hope that helps you decide whether you want to buy one of these, and we'll see you next time.